This is problem 7.2, number 66. Household electricity is supplied in the form of alternating current that varies from 155 volts to a negative 155 volts with a frequency of 60 cycles per second in hertz. That's the unit for frequency. The voltage is thus given by this following equation, where T is measured in seconds. Voltmeters read the RMS root mean square voltage, which is the square root of the average value of E squared over one cycle. Calculate the average voltage of household current. So I think that what would throw people off here is just the wording altogether on this. You just want to know what E squared is, first of all. So let's go ahead and say this implies that E squared, E of T being squared, is just going to be 155 squared sine squared of 120 pi T. And then they want to know what the root mean square is. Well, that's just the average value of this function over a single cycle. That's where we have to think here. So let me go ahead and highlight that. Over one cycle. Well, we know we have 60 cycles per second. So one cycle takes 1/60th of a second. So we want to know what is E squared average. It's supposed to be an AVG there. But over one cycle. The average over one cycle. So that means we're going to use the average value function. And we're going to integrate from time 0 to time 1/60th of a second, because again, 60 cycles per second, we only want to know the average value of a single cycle of E squared. So the coefficient is going to be 1/60th minus 0. And we're integrating that 155 squared sine squared of 120 pi T dt. I am going to go ahead and factor that 155 squared out to at least start the thought process here. And obviously that's going to be 60 times 155, but I'm just slowly kind of working my way through here. And we're integrating from 0 to 1/60th of sine squared. Well, let's see here, dt. So how are we going to do this? I would like to somehow integrate a sine squared, and I can't. If you try to let's say u equal sine squared, or sine, sorry, then du is going to steal away a cosine, which we don't have a cosine to steal, so that's worthless. If you let u equal cosine, it'll steal away a sine, the derivative will, and we'll end up with a single odd power of sine, which is not going to be worthwhile. So doing a u sub is not going to work. However, using a half angle identity will definitely work here. So this is going to be 60 times 155 squared. And we're integrating again from 0 to 1/60th. And the half angle identity for the sine is going to be 1 minus cosine of twice the angle. So 2 times that 120 is 240 pi t over 2 dt. And we can actually clean that up. I'm going to pull the half out front, so it becomes 30 155 squared. And then we're just integrating from 0 to 1/60th, 1 minus the cosine of 240 pi t dt. The antiderivative of 1 is t in this case. And the antiderivative of the cosine is a sine, so we're going to have minus a sine of 240 pi t, and then we'll have to offset that multiplication of 240 pi by a division by 240 pi. And this is from t equals 0 to t equals 1 over 60. Finally, substituting in, we will get 1/60th here minus 1 over 240 pi times the sine of 1/60th of 240. That's going to be 4 pi. And then when you plug in zeros, everything zeros out, so it's okay. So I'll bracket that there. But sine of 4 pi is 0, and so we get half of 155 squared. And let me check really quickly here. Calculate the RMS, root mean square, which is the square root of the average value of this. So that's actually kind of a trick here. It's the square root of the average value. So we just found the average value of E squared, but the root mean squared is the square root of that average value. So the root mean square, let me go and write this here, root mean square is equal to the square root of that 155 squared over 2, which is actually going to be 155 over root 2, which is roughly 110. And the units for that are E, which is going to be volts. Yeah, voltage. So that's volts, 110 volts. Okay. Not too terrible so far. Let's see what part B is asking. Many electric stoves require an RMS voltage of 220. Okay. Find the corresponding amplitude needed for the voltage E, which is A sine of 120 pi t. So we just need to figure out what we would do. Well, that almost seems like you would just double up that 155. But just in case, let's go ahead and redo the problem. And actually what I'm going to do is I'm going to go ahead and just copy all this stuff right here. And maybe I should pause while I do this. So here we are. I just copied all of our work. Now, what we actually want is we want the square root of that average value, that average RMS value, or not average RMS. We want the RMS, which is the square root of the E squared, to be, I totally forgot what it was, to be 220. Okay. So what I'm going to do, I copied all the work, and I'm going to, in blue here, just go ahead and say, I want the square root of this to be, shoot, I keep forgetting, 220. Okay, so I want the square root of this to be 220, but this time instead of 155 out front, it's actually, we just don't know what the amplitude is. That's all. So we're going to do all this problem with this unknown amplitude in a square root. And actually, there's not much that we need to worry about here because most of our work is identical. So I'm just going through and replacing all the 155 squareds with A squareds just to showcase that everything else is the same. We just want this in the end to be 220. Now remember, our logic, what I had said was that we probably want that coefficient to be, instead of 155, to be twice that, because we just want to double up the voltage. Well, let's see if that works out. We want 220. Oops, there we go. 220 to equal the square root of A squared over 2. Or in other words, if you multiply both sides by the square root of 2, you get 220 root 2 to equal the square root of A squared, which will be A because it's a positive amplitude. And grabbing a calculator, this is roughly 311 volts, which is exactly what you would think it would be, because if you double up the 155, it comes out to 310. So it's just been rounded slightly differently, but still, that's what we need the average, the RMS to be to reach 220 volts. That's it on that one.